So after doing that binatone hand portable, we ended up with the squelch being intermittent, and after an awful lot of time it turned out to be a leaky diode. There's 4 diodes in the radio. We'll find... no, I can't. But there's 41 and 4148 diodes in the radio, and we must have hit on the right one because that cured the problem. But it was an awful lot of time doing that. So now we've got quite a corroded radio. Not sure whether we're servicing this, but we are servicing this because it's here. We want a replacement front. We just happen to have got a set which was beyond economic repair here, so we could have the front off that. It's got a problem in the VCO on this one, and it's one of those that's been turned into something it shouldn't have been, and then, you know, it's had the kiss of death. So we'll use that one's front. So it's got some rubbing down of that to do. It's pretty corroded. So let's see what the issue is. I forgot that the speakers are still connected on these. They're not plug in. So I know this gentleman does do some servicing work, but I'm not sure what we're doing to this. Well, I'll tell you what, I'll swap his for ours and just charge him £1. How about that? It's lost its mounting things. What we'll do, if I ever manage to resurrect that... oh! Ours is just as bad. Oh dear. Ours is just as bad. Well, that was the end of that idea, wasn't it? I knew we'd got this, but I didn't realise that ours was glued on. Oh well. That didn't work out for him, did it? Well, he's going to have to do the same. Okay, so we'll do a service and there we go. What a shame. Something else that needs glue gunning on this is that connector. Right, we'll plug that into the test gear. We're certainly receiving. Let's see if it's transmitting. It's doing more than that. That switch isn't right. It's probably broken. So we'll just have a look inside there. He's going to be the most disappointed customer in Britain because he's ending up with a set no better. So what's happened here is the moulding's failed on the microphone. So when you press the button, it's all not in the right position. That's another glue gun job, isn't it? I hope he's got a glue gun. Okay, so we'll unplug the extension speaker because that's obviously going to cause us issues. Radio's doing 3.6 watts. I'll get a piece of paper, we'll write down the parameters. TX 2779146 3.6 watts. Deviation Wallow. Am I on channel 20? I am on channel 20. Why are we not getting any Wallow? Because of the mic. 1, 2, it's about spot on. It's 2.2. We'll just pop that down a fraction. I'll put that up on the picture-in-picture. If the picture-in-picture's on, there we go. So there's our power at the moment. So it's greater than our 3 watt range, and it's about 3.6. Over to deviation. Wallow, it's just over about 2.2. It's just can go up a little fraction. So what we'll just do is we'll put the frequency counter on, pop that down a bit. It's well in spec. It's just I may as well just trim it while it's here. They drop naturally with age, so I'll keep them slightly high. So let's go through the transmitter, see if we can get anything else out of it. I think that's transmit. This is one of those sets where you haven't got any variable inductors in the output stage, and this is one of those where we may need to just adjust the way the shape of the coils are, not in this section, in this section, because that would affect the filtering of the second harmonic. And that's spot on the 4 watts. So go back to that screen, and there we have the 4 watts. So I've pushed one down and lifted one up slightly. Good. So deviation, can't remember where anything is on these sets. Chances are deviation is that one. Let's get the oscillator out. 1, 2, wallow, 1, 2, 1, 2, wallow. You know, I've turned that and it hasn't made much difference. How come? One, two, wallow. Don't tell me there's two like there are on a Cybernet 134. So I'm expecting that to be transmit meter. Is this deviation? That must be the other deviation one. So one's mic gain and the other's... I'll put that to central position and then we'll use this one. One, two, one. Now it's over the top. One, two, 1, 2. One, two, 1, 2, 1, 2, 1, 2, wallow. That seems about where maximum we're going to get. So that's done the deviation. So the transmit meter is going to be one of those two. Ain't that one. Not showing us that one. Let's go to low power. Low power's on the back. Let's see what it's doing. Far too low. So 27, still that's what pulling up now. So that's 400 milliwatts now. So which one of these is going to affect that meter? It's that one. So go back to high power and we've got all four. So that's where it wanted to be. We've done the TX meter, so we know the back one's the RX meter. So I think we've done all the transmit bits there. So let's move over to the receive, which sounded quite good to be honest. So plug that in. So we'll look at RX, go to the SINAD meter, and he's asked me to look at his SINAD meter as well while it's here, so I can only calibrate it against mine, so we may as well do it with his set as well. So let's have a look. What's his radio doing? Wow. 0.26 of a microvolt. Well, I won't be improving on that, I'm sure. So just run through it. Drop that to about 4 dB with by turning the attenuator down. Never did get to the conclusion as to whether this is transmit or receive, so we'll just find out. So it must be transmit. We'll go back to transmit. We'll go back to transmit at the end because I don't have to keep plugging the speaker in and out. Pick a signal for the next one. and then the detector. So we'll put the oscilloscope on for that. Turn the bench light off, make sure that's maximum. Very slight improvement there. Let's see what his SINAD reading is now. Let's go back to the SINAD meter. Oh, before we do that, we'll just do S9. So it's throwing 3 at the moment. So we know it's that back one. We want that one to just light. That's it. So back to those SINAD readings. Yeah, 0.26 a microvolt. It's not going to change. So we'll check the squelch. So I want it to come in at S9 equivalents. Put that on the attenuator so you can see me do that. So 1 microvolt, 3 microvolts, 10 microvolts, 30 microvolts, 100 microvolts. Yeah, it was spot on. It was spot on. And minimum. Switch the single generator off. Switch the squelch to threshold. Switch the signal generator back on. Come straight in at 0.3 of a microvolt. So it's 0.3 to 0.25. Excellent. Well, that's it. That's covered that multitude of sins. Yeah, I bet he'll be pleased to get 4 watts out of that. So he needs to glue gun that. He needs to glue gun those that front, and it's going to be a glued on radio. It's a shame when they get to this kind of stage. And they were nice and expensive sets at the time. I'll put it on the aerial and see whether we can hear anybody out there. It's exceptionally sensitive. One on a Roger. It's got mic issues. One thing we will do, I forgot to go back on that transmit coil that I disturbed. Just turn the volume down. There we go. Reset. Fine. So, sorry we couldn't do anything with that. I knew we'd got one in stock. I didn't realise it was also broken. So, I've had him send that in really for nothing. So, we've done the service. We've gained something out of it on transmit. Sorted out the low power. And all I can do is advise him on that mic. There's an issue with the wire as well. So it's kind of a trade job for somebody else who's into the service business. So that can go to Wales. We're going to look at his SINAD meter he's sent in. I've never looked inside one, but basically it's going to be an FM receiver with a bit more added. So there you go, Cybernet Beta 2000. We've covered them before, and the transmit was there, and we just had to adjust the coils there to bring it up to 4 watts. I don't like having to do that, but that's how it has to be done. Then on receive, we've got the front end here, the IFs there, and then we've got the detector there. We've got mic gain, mic deviation, low power, squelch, receive meter, transmit meter, and there we go. So thank you for watching Cybernet Beta 2000 from 1981.